How does math help us build bridges and buildings? Why is math important in building? Have you ever looked at a tall building or a long bridge and thought, wow, how did they make that? The answer is simple: math. Math is like a secret tool that helps engineers and builders design, plan, and make strong and safe buildings and bridges. Without math, these amazing structures would not be possible. Let's explore how math plays a big role in building bridges and buildings. Math helps us make strong structures. Every building or bridge must be strong enough to hold weight and stand safely. To make sure of this, engineers use addition and multiplication to count materials, geometry to measure shapes and angles, algebra to solve problems, trigonometry to work with angles and heights. Example: if a bridge needs 10 beams, and each beam is 5 meters long, then the total length is 10 times 5 equals 50 meters. So, math helps us know exactly how many materials we need. Measuring everything: length, width, and height. Before we build anything, we need to measure things correctly. Math helps us measure how tall a building should be, how wide a bridge should be, how long the pillars should be. Measuring everything: length, width, and height. We use centimeters, cm, meters, m, kilometers, kilometer, for very long distances. Example: to build a wall that is 3 meters tall and 5 meters long, we use area equals length times height. Area equals 5 times 3 equals 15 square meters. So, we know how many bricks we need to cover 15 square meters. Geometry: understanding shapes and designs. Geometry is the part of math that deals with shapes, lines, and angles. Builders use geometry to design rooms, square, rectangle, circle, make sure walls are straight, fit windows and doors correctly, build round or triangle-shaped roofs. Example: a triangle is one of the strongest shapes. That's why many bridges have triangle patterns in their design. It helps them carry heavy weight. Algebra: solving building problems. Sometimes, builders face problems they don't know the answer to. Algebra helps them find the missing values. They use letters like x and y to solve how much material is needed, what height a beam should be, how long a rope or cable must be. Balance and symmetry: making sure it doesn't fall. Example: if one side of the bridge is x meters and the total bridge length is 50 meters, then x plus 30 equals 50. Solve for x. X equals 50 minus 30 equals 20 meters. Now the builder knows one side must be 20 meters long. Estimation: planning before building. Before starting, engineers must estimate cost of materials, number of workers needed, time required to build. Math helps them guess the total cost and time using estimation and rounding. Estimation: planning before building. Example: if one brick costs 8 rupees and you need 1,000 bricks, 8 rupees times 1,000 equals 8,000 rupees. That's how much just the bricks will cost. Using patterns for beauty and strength. Math is full of patterns, repeating designs. Builders use patterns to make things look beautiful and strong. You might see tiled floors in a repeating pattern, arches in a building, spiral staircases. These are all examples of math in art and design. Example: a spiral staircase uses math to make each step the same size and the same angle apart. Fractions and ratios: mixing materials. Many building materials must be mixed in the right amounts. Like cement, sand, water. Builders use ratios to make perfect mixtures. If they use too much of one thing, the building could break. Fractions and ratios: mixing materials. Example: to mix concrete, they may use 1 part cement, 2 parts sand, 3 parts gravel. This is a ratio, 1 to 2, 3. It keeps the mixture strong. Area, volume, and perimeter: knowing the size. When building rooms, tanks, or pipes, we must know area, flat space, perimeter, outside border, volume, space inside. These measurements help us use space wisely. Area, volume, and perimeter, knowing the size. Example, if you want a water tank that holds 2,000 liters, you must find the volume. Volume equals length times width times height. This tells you how big to make the tank. How math helps in building bridges. Bridges need math more than anything else. Why? Because they must hold heavy loads, like cars and trucks, must not shake too much, must be the right length and height. Math helps engineers plan everything perfectly. How math helps in building bridges. Example, to build a suspension bridge, engineers use geometry to design cables, algebra to calculate loads, trigonometry to measure angles. Real-life examples. Burj Khalifa, tallest building, uses math to balance its super tall structure. Shapes help it stand strong against wind. Golden Gate Bridge uses triangle shapes for strength. Cables are carefully measured using math. Real-life examples. Our own home. Rooms are measured in square feet. Bricks, tiles, and paint are calculated using math. People who use math in construction. Many people use math while building, like architects, design the building. Engineers make sure it's strong and safe. Builders measure and use materials. Electricians and plumbers use math for fitting wires and pipes. Without math, their work would be messy and unsafe.